afternoon, everybody. My name is Elaine Ross-Purse. I am the project manager for Elk Construction Consultants, and today we'll be going over where we are at with our finalization of our Amazon industrial site projects. Today with me I have Chance Traxa, Chris May, Elizabeth Walker, and Kim Frank, and you can see the disciplines here. So I'm going to start with my aspect. I am a transportation engineer as well. And so for our scope, I'm just going to give a little bit of a review. The transportation scope includes one new connector from County Road 4 to County Road 19, which may include work to the toll road entrance, as you can see here. Additionally, it must provide access to any facilities that are on the project site, and I must also design any parking lots as well for these facilities. So for the design criteria that I've been using the Indiana Design Manual as well as supplementary materials from the AASHTO Green Book, and any other individual materials I've been using, the code, the Elkhart County codes for things such as parking lots. So I'm just going to review my alignment alternatives. I have presented them before, but I would just like to give you a quick overview of what they look like again. This is my first one. It is a kind of curving connector, which will also entail some realignment of the toll road entrance here. It will start at the County Road 4 and go down and come to a line where our warehouse will be, which will be somewhere around here, and then we'll connect into County Road 19. This is the alignment alternative B, which you've also seen before. This is kind of just a straight east to west bisector. It will be kind of more aligned already with the warehouse facility, and additionally it will connect into an existing intersection on the toll road entrance, so there will not need to be a huge major redesign of that intersection. However, that does mean there will be different intersection design if chosen. Additionally, this is alignment alternative C, which as you can see kind of does have two different components. There is one that is more so another bisector as well, and then there is the other alternative within this that is kind of the curving down to meet the access, to have more access to the facility. However, to note, this one does go through the wetlands, so this was originally designed to have minimum impact to the toll road entrance because that will have heavy traffic. However, it is important to note the mitigation of the wetlands. So kind of with construction cost estimates of these designs, alignment A is about $7.7 million, alignment B is about $5.6 million, and alignment C is about $6.4 million, and I just provided a sample calculation for that cost, and I can answer any questions on that later if you'd like. Additionally, I forgot to say, I use the INDOT unit price summary data sheets to help do these preliminary calculations. Additionally, this is a parking lot design I've decided to go forward with. This is due to the requirements for the amount of spaces and also what our facility will be used for, which is a warehouse, which will have unloading down here at the back side of the facility. It will also have truck spaces for parking while it's waiting to unload, and additionally it will also have office spaces, like spaces for those who work in the office. So the evaluation criteria that I use, the three key parameters were construction costs, real estate efficiency, environmental impacts, time of construction, and access convenience to the warehouse facility. This is due to these kind of seem like the factors most important to what would actually help in transportation, especially with the use of this facility that we have. I kind of just wanted to show you guys this evaluation matrix, but I will also go into that more if you guys have any questions. There is a weighting. Construction costs and real estate efficiency were the highest because there was not as much pedestrian worry here with this facility. Access convenience was also the second most important criteria, as there will be a lot of trucks and we want to make that easier on them. Additionally, each of these parameters would be scaled up from 1 to 5, and with 1 being the worst and 5 being the best. And this is kind of a summary table of these scores for each of the alignment alternatives. And I also just provided the construction cost estimate as well, so you can review that when you look at this graph. Additionally, with this, so it came out that alternative B had the highest score, which shows that it has the most beneficial parameters. And just to review, that was the east-west bisector, and therefore, because of the criteria and how it's scored, it is now the preferred alternative to the transportation component. Additionally, I want to show you the intersection details on this alignment. It's kind of as is scoped by a previous study that we were provided. There may be some details that change in future, especially with this other intersection, as it is not as anticipated by the original scope. All right, and with that, I would like to hand it off to Chance Traxa.
Thank you, Lily. As Lily mentioned, I'm Chance Struxa. I am the structural lead here on the Amazon Park Industrial Redevelopment. So first, just kind of my scope of work. So I was tasked with designing the building for the location. I opted to go with a warehouse. This is due to functionality. So the client wanted office space, reception areas, loading and unloading spaces, and so forth, and a warehouse was the best option to accommodate all these needs. So I then had to determine the location of the warehouse, which you can see on the right side of the screen. I obeyed local building codes, developed alternative options, and then chose the most feasible alternative of those options. So just a quick recap. This is again from Progress Presentation 1, but just so we're all on the same page. We have our two-story floor plan, applicable to alternatives 1 and 2. On your left, we have the ground floor featuring the storage space and loading space. And on the right, we have the upper floor featuring the office and reception areas. This was done like this. Nobody wants heavy-duty loading equipment like cranes next to your offices. It's not practical and it would be in the way of the workplace. So here's the one-story alternative. This is for alternative 3. Again, the same spaces that I previously mentioned are all here, except in this case, they're all on one flat level. So quick recap of each alternative. First, we have our two-story reinforced concrete alternative. Here, everything is reinforced concrete. Roof beams, slabs, you name it, it's reinforced concrete. One thing worth noting, the slabs in all 3 alternatives are going to be reinforced concrete. With the strong compressive loadings expected from the warehouse, it just makes logical sense. I'm not going to go into a bunch of details on all the beams as that was covered in presentation 1 and is detailed in the report. I'd be happy to talk more about that in questions if there's any about it. Alternative 2 is our two-story steel alternative. Same layout here, again, not a whole lot else to say, except that in this case everything is made of steel minus the slab. Alternative 3, same scenario, all steel, except here we're back to that boxy floor plan where everything's on the same level, but again it's all steel with a concrete slab. So now for the meat of the presentation, choosing which alternative is necessary. So I used a variety of different criteria to do this, including construction cost, real estate efficiency, environmental impacts, time of construction, and floor plan convenience. Each of these categories was weighted based on what we thought was the most important. 5 being the most important, 1 being the least. We decided that construction costs and real estate efficiency were more important just based on what the client wants in the building. Then each one was also rated according to the categories below, with 5 being excellent and 1 being the worst option. So then based on that criteria that you just viewed, we came to selecting an alternative. Alternative 1, the two-story concrete, came out with a score of 57. Alternative 2 came out with a score of 73. And alternative 3, a score of 48. So you'll notice alternative 2, a substantially higher score than the other 2 alternatives. A lot of this was mainly due to the real estate confinement criteria as well as the cost criteria. So the concrete building failed in the cost section. When doing an RS mean square foot estimator, it was significantly more expensive, so it was ruled out. And then the one-story steel alternative failed in the real estate confinement segment due to it taking up double the square footage. It takes up 35,000 as opposed to 17,500. So with that, a basic cost estimate of $4,620,000 is noted for alternative 2, the chosen alternative. This cost includes a 20% contingency for any overhead or any other hiccups that might happen along the way. With that, I'll be handing it off to Chris, our water resources engineer.
This is Chris. I work for water resources. Here's my scope for it. Mostly just like due to system, which is flow control system, water quality system, to treat the problem and clean acid, and also make sure it's obeyed the local regulations. Here's my term 1. It's mostly like use the rain garden to treat the water from the building, from the side, and also I'm going to use those wells to like guide the flow to make sure that most of the water can be treated and goes to the dry pond. Also, I will use the vegetative wells along the road to make sure that water from the road, the polluted water from the road can be treated. But so the vegetative wells for the road, it's the same for the alternative. As we can see, I set the rain garden and dry pond at different 3 places just due to that's the low point, so I want to make sure that water eventually can goes to the BMP and goes to the dry pond. And next is alternative 2. I used permanent pavements to treat the water, and you use the shortest swells to make sure to save some money and make sure the water can eventually goes to dry pond. And also there's swells across the road to make sure the water from the road can eventually went to the dry pond. And I also set grass filter strips to do a security for make sure it can treat the water well. And next is alternative 3. It's like use a green roof, which is pretty good, to like treat the water from the building. But the green roof only can treat the water on the building. So I gotta use another BMP, which is rain garden, to treat the water from the parking lot and use as well to guide the flow, and also eventually make sure it goes to the dry pond. And next one is the alternative 4. That's kind of new idea because I want to combine the flood control system and water quality system together. Just due to the wet pond has a pretty strong ability to either both storage the water and to treat the pollutions, especially treat the solids, and with the bioretention system. So also I'll use the shortest as well to make sure the water goes to the wet pond eventually. And I'm also doing another security for wetland buffers to make sure the water can be treated well and like follow the required employees give us. And here's my cost analysis based on research paper we did, which is the cost analysis of different BMP. And here's my construction estimates. As we can see, alternative 3 might be pretty higher than the others, just probably due to it's not the data we have. It's not really uniform. It's not uniform. It's based on different situation, condition, based on different areas. So it might have some mistake, but that's what we got. I guess we see alternative 4 is the lowest. It has the lowest cost, and that's my evaluation criteria. I know there's most of us put the cost as the highest point, but for me, the treatment efficiency is the most important thing. You need to meet the about what they require. So that's what I got. After I put the number in, I get the eventually points, which just shows the alternative 1 has the best performance. And so I would choose. Eventually, I would choose the alternative 1, which has a $0.87 million, and it looks good. It's just due to the rain garden. It's a pretty good looking BMPs, and it's visible just due to there's not a lot of BMP. It's not complex. It's easy to either design or build. So. And it also has a well-finished to pollutant treatment required. It's just because actually the rain garden has a rain garden is a pretty good BMP. It's efficiency, good looking, and also treat the pollutant well. So, but like for all, it's like mediocre but stable, which means as we can see, the alternative 1 doesn't have any of criteria in the highest point, like. But eventually you get the highest point. So for me, it's not. There's not any points special, but it's the best one. With that, I'll give it to Elizabeth.
My name is Elizabeth Walker. I'm one of the environmental engineers for LCC. Just a quick recap of my scope is to design a wastewater treatment facility to treat 1 million gallons per day. Included in this is the determination of the biological treatment alternatives, the cost of those alternatives, and making sure everything is up to local codes. Just a quick overview of my alternatives. My first one is activated sludge. This is the conventional treatment, and for good reason, because it has the highest efficiency, 90 to 95% of BOD removal. And this treatment involves using aeration tanks to promote the growth of microorganisms, and those break down the pollutants from the stormwater. My second alternative is the trickling filter, which involves water being sprayed over a bed of media, such as rocks or plastic, and biofilm grows on that media. And the microorganisms within the biofilm consumes the fluids of the water. One thing about this treatment is that it can be affected by the weather, especially in northern regions such as Indiana. My third alternative is the rotating biological contactor. It has a very low space requirement, and this involves rotating discs passing through the water, and it works the same way as the trickling filter, where a biofilm forms on the discs, and that kind of consumes the fluids and water. So the alternative analysis for my project is based on some key parameters, including cost, land usage, discharge quality, efficiency, and operations and maintenance. And each of these parameters was given a weight. I chose cost to have the most heavy weight out of 5 because we want to make sure we're not breaking the bank. And then the next highest is the efficiency. It's really important that we're getting our discharge effluent to the proper standards as required. So each alternative was rated on a scale of 1 to 5, 1 being poor, 5 being excellent. So the ratings for activated sludge, I gave cost a rating of 2 because this is quite a bit more expensive, between $3 and $7 million typically, and these numbers are for a 1 million gallons per day operation. Land use received a 3. They take up a good amount of space, up to 5 acres. Discharge quality 5, efficiency is 5 because, as we know, 90 to 95% BOD removal. Operations and maintenance scored a 1 because these treatments do require really skilled personnel to be there basically at all times, making sure everything gets running smoothly. Just a lot of adjustments need to be made. For my second alternative, I rated cost of 3, the typical range being $2 to $5 million. Land usage was given a 3. These are kind of a sprawling, like you wouldn't think it takes up that much space, but it not as much as activated sludge. About 1 to 3 acres. The discharge quality, I rated a 4, and efficiency is a bit lower at a 2 because we have 60 to 85% BOD removal. So this practice is best paired with another treatment after the fact, a secondary one. Operations and maintenance received a score of 2 because they do require periodic maintenance and cleaning. The alternative 3, the RBCs, I gave the cost a rating of 3. These are a bit less expensive, about $2.5 to $5 million. Land usage was rated a 5 because they take up a very low amount of space, only like 1 or 2 acres. They're very compact. The discharge quality and efficiency, I gave a 3. Similar to the trickling filters, these are best paired with secondary treatment afterwards. And operations and maintenance received a 2. So this is just kind of all of that condensed into 1. And based on the weighted comparison matrix, the ideal alternative is activated sludge. And that I'll give it to Lynn.
Hello everybody, my name is Caitlin Frank and I am the second environmental engineer, a part of LCC. My scope work, I was tasked with designing a water treatment facility designed to treat 1 million gallons of water per day. I had to determine the location of the treatment facility and fire protection within the property for the facilities that will be located on the project site. I had to determine water source alternatives and design according to local and national standard codes. I had to determine the cost of these alternatives and then make a final selection of one alternative that would be best for this project. The proposed location of my water treatment facilities and the fire protection within the property is shown right here. So if we decide to use groundwater treatment, that facility will be located in the northwest corner of the project site. If we determine that surface water would be a better option, that facility would be located to the west of the building location, the facility location. 2 fire hydrants were placed on the property in order to account for fire protection, just in case anything happens at the facilities. Reiterating my alternatives, my alternative 1 was a surface water source, which would come from St. Joseph River. This presented with characteristics like high flow quantities, but bad water quality characteristics coming from pollutant sources which directly impact the water source, such as the failing on-site septic systems, direct discharge of septic tank effluent, increased development in agricultural practices, which lead to pollution. It is far in proximity from the proposed facility location. It's approximately 2 miles in a distance. The intake structure for this alternative would be a culvert with gravity flow piping for transport to the treatment facility. And the piping that would be used for this, based on the flow rate calculated, is an 8-inch ductile iron pipe. Treatment trains were also developed for all of these alternatives. So if we were to go with surface water based on the pollution levels, we would start off with a rapid mix going into a flocculation basin, since it's good for TSS removal. It would then settle in a sedimentation basin where it goes off to a rapid sand filter through disinfection and then to water stored before being taken to the water distribution system. Down below, I have calculated the estimated project cost if this alternative were to be chosen, taking into account intake costs, treatment costs, storage costs, and then fire protection as well for those hydrants. My alternative 2 is another surface water source, which would be taking water from Heaton Lake. Heaton Lake is located to the west of the property. Some characteristics about this one are that it's closer in proximity to the proposed water facility than the St. Joseph River. It's only about 1.13 miles, so roughly half of the distance of the last surface water source. This is a consistent water source and would produce over 1 million gallons a day, but it also is a pollutant source and it has existing on-site wastewater disposal systems. The intake structure for this one would be a submerged pump with iron ductile piping again for transport. The treatment train for this one looks exactly the same as the first one. Since both water sources experience pretty heavy amounts of pollution, we want to make sure that it's getting to the water quality it needs to be. And then this one also took into account the intake cost, treatment cost, storage cost, and fire protection, being roughly $4,068,240. My alternative 3 was examining a groundwater source. All Elkhart's existing drinking water already comes from groundwater. It's what they use for all of their drinking water. So in the case of this, we would be using a private well installation, and based on redundancy requirements, it was calculated that 3 wells would be required in order to produce 1 million gallons of water per day. Some characteristics about this source is that it experiences low turbidity, but it also has high levels of water hardness, so we had to account for that in the process of the treatment train. The intake structure for this one would be a well with a submerged pump, and that would be 16-inch ductile iron pipe for transport. The treatment train determined for this one starts off with the water intake coming from the underground wells. It would then go through a chlorination process, pre-oxidation stage, settle in a sedimentation basin, go through a rapid sand filter, and then the softening treatment would be a lime soda softening treatment in order to account for the water hardness levels. Where it would then go to a water storage tank before it's pumped to the water distribution system, taking into account intake costs, treatment costs, storage costs, and fire protection. This one ends up being roughly $3,976,040. Now moving on to the alternative evaluation criteria, some key parameters determined for this portion of the project were cost, land use, water quality, efficiency, and operation and maintenance. The 2 highest weighted categories that were determined were cost and water quality. The water discharge coming from this facility will be used as potable drinking water, so we want to make sure that it is up to its highest standards. And obviously cost is important in order to make sure that the project is feasible for the owners. After evaluating all the different characteristics of the alternatives, it was determined that the groundwater source, also known as alternative 3, ended up with the highest score from the alternative selection and evaluation. So with the 20% contingency fee, the total estimated cost of this alternative would end up being $4,771,248. And I will be handing things off to Chance to talk about some total costs.
Thank you, Caitlin. So as Caitlin mentioned, I'm going to be discussing total costs. This first slide here is the design cost estimate, which is after tallying up each discipline, comes out to a total of $39,000. These rates that you see here already factor in overhead and everything like that. giving us that expected cost for phase 2 of the design. One thing I should note, myself as the structural discipline, I will be continuing my career at a different company next semester, so my role will be overtaken by somebody else most likely. So then we can go into the construction cost estimate. We each have a total, as you see here, summed up, and then have a general estimate of $23 million. Again, these costs are higher than what's likely to actually be. In the case of structurals, RS means square foot estimator, accounts for furnishings, flooring, all those types of things that are accounted for in this estimate, but are not actually in our scope. With that, we'd like to thank Dr. Weiss, Dr. Schickel, and Dr. Devani for coming, as well as HHBS for allowing us to present before them, and we'd be happy to take any questions from you all.
Just a minute. So I'll ask while you have any good. So Chris, so I noticed on your slides or alternatives you had swales and bioswales, and then you also mentioned vegetative swales. So are some of those the same, or how do they?
Bioswale is the same as vegetative swale.
Okay, then in your alternatives, you had bioswales and swales. So I know the bioswale is by the road, right?
Yeah.
Well, where's the swale, and then what's the what's the difference that it's not a bioswale?
Actually, the swale it's right there. Some right there.
Where? I can't.
The purple one. Is it?
It's next to the buildings.
Like right there. So just try to.
Oh, that's purple?
Yeah.
Okay. Light purple?
Just try to guide
Visible
the
purple.
flow to make sure it goes to a dry pond and or a rain garden or something.
Okay.
And the reason why I didn't do the vegetative swells at the lodge is because the vegetative swells it's a little bit expensive than the regular swells, and I feel like the BMP we have, I use it's enough for treat the water, so I don't have to use a lot of money to build that.
So what are you treating? What pollutants are you targeting?
Solids and metal.
Okay. So you think the rain gardens will do a good job with that?
With the dry pond, yes.
Okay.
I have 2 rain garden actually
Yeah.
for this one. So I think with the dry pond, I think so. Based on the research I did.
Do you have any concerns about the rain gardens not doing well with some other pollutants?
I never thought about that problem, but I think it's gonna treat the solid and metal wells. For others, I don't know actually.
Okay. Thanks.
Yes, sir.
Lily,
Yeah.
what is the cross section of your roadway
Yes.
look like? You can use the blackboard if you like.
Oh, the little sketch going. Would you like me to draw a sketch?
You could tell, if you can
Okay,
describe
I'll
it in
describe
words,
it
that'd be
first.
great.
Hold on. Let me get there. So that is going to be based off of this design criteria. It will be a typical crown section. It will have 12-foot wide lengths. So,
Do we have markers?
okay, so you will not be getting a sketch right now. But, so typical crown section, which will also additionally have a width of a shoulder, that is a gravel shoulder, which it says paved shoulder width here, but that is based on like IDM 53.8. However, I've chosen to go with a gravel shoulder. Yeah, don't count that as bad part of my grade.
You're a soccer player.
Yeah, I use my. Anyway, so we have a crown section which will have a 2% grade on both sides. A little bit of a shoulder here. There will be a 4 slope of, as you can see, a 6-to-1 grade. And then I don't know what to say the back slope on there. Anyway, there will be a slight swale here which will additionally be helping with the water quality measures, and then you'll have I can't remember what it is, like a. At this time, I do not remember, but additionally, it'll just be like this kind of typical crown section that you would see on most roads.
Okay.
Yes, sir.
I have a question. So,
Yeah.
you mentioned you're not going to be here next semester. Will you be continuing your work at Hunter Engineering at IU?
I will not. I will be continuing my work at LFA in South Bend.
Okay, that's good to know. Thank you. I think you had a question.
No, you go. I'll get the last one. All right, so you have a single-story alternative and two two-story alternatives?
Correct.
Is that following like the framework of like a single double framework?
No, it is not. I just came up with that criteria. Primarily just to use different materials and have different floor plan layouts for alternatives. And in the end, we ended up selecting the two-story alternative because it saves on space and is more efficient.
All right.
Yes, sir.
In your layouts for the two-story, I didn't see any stairways or elevators. Will you be building this building in accordance with ADA regulations?
We will. So on the two-story alternatives, an elevator will be put in. That's outside my scope. I designed a spot in the hallway, which can be shown on the where's it at? On the cross section. It's not on this floor plan, but over here on each side of the hallway, there will be an elevator on the two-story alternatives. Since we selected a two-story alternative, yes, we're going to have an elevator put in. All we as structuralists have to do is design the location for the elevator. That's outside our scope. That's an architectural scope to put the elevator in.
Okay, thank you.
Yes, sir.
I have a question for you. In your alternative, you said that you are going to use the same layout for steel structure and also for the concrete?
For both two-story alternatives, same beam layout and same floor plan. So that was just, the idea here was just to compare different materials and their costs with the same floor plan being used, because we didn't want to have expense differences with different floor plans when there's no reason to do that because it's two different structures.
But generally, we use less number of beams and girders in the concrete.
Well, this was all,
structure.
like, again, these alternatives haven't been officially designed. That would be in phase 2 down the road. This was just to get a general guideline as to what the cost would actually be. And when I ran the
Yeah,
RC's cost.
that's actually the problem, because that raises a question that you probably overestimated by putting more number of beams and girders.
Well, I used
You overestimated the concrete cost.
I would say overestimated the steel cost, because typically you would use, like in the concrete, I would have girders and things in there, right? So I would say overestimated the steel cost, because there's actually more steel girders than what's needed.
But you're saying that the layout of the beams and girders is the same for steel and concrete, right? So you're using
Just
the same.
in this theoretical comparison, yes. In the actual design phase, they would not be. This was just to get, I understand what you're saying. You're saying that technically the spacing would be a little bit different, which would lead to different costs. But the cost of the concrete, it can be detailed in the report, it's not in here. But the cost of the concrete was not even close to the steel alternative.
Okay.
Like, not even close. So that's why we selected the steel. If it was where the numbers were actually like very similar, then absolutely you're right. I'd go in to make sure the spacing's actually technically accurate. But since the numbers weren't even close, like slightly modifying the different spacing, it's not gonna drop the cost that much to where they're comparable.
Yeah, I was going to continue because somebody tipped me that you're graduating, I have to give you a hard time. But anyway, I have another question for transportation part.
Of course.
In your cost estimate, this is like the implementation estimate or material estimate?
It is both, actually. So using the,
So if you go a couple
I
of
don't actually-
pages, yeah.
So this uses the NDOT unit price summary data sheet, which actually does consider both the construction costs, like the labor involved, and the materials price as well.
The reason that I'm asking, because some of those units, if I'm reading right, for example, for sub-base or aggregate base, of course, Professor Schickel would
Yes.
be like better judge of this, but I see the units of cubic yard.
Correct.
Generally, these units are, if it's for implementation, these units are units of square yard for a specific thickness. For example,
Yeah.
the unit cost is for like square yard for 2 inches,
Yeah.
3 inches, or 4 inches. So I
Yes.
just was wondering if this is material or like.
It is both.
It is both.
It's kind of like the NDOT tables is kind of complicated to read, but I did read through like all the.
So you use the INDOC table for.
Yes, correct. These values are pulled directly from that.
Thank you.
Yeah, of course. Any other questions?
Yes?
Good chance.
Okay,
So back to your floor plan,
yeah.
is there a particular reason why you use the color orange instead of eye red?
It was just an arbitrary choice. I wanted something that stood out. So no, I do not have a particular reason as to why I did not use red.
They like it,
Yes.
they don't want it to
Another
graduate.
question,